Hey guys, you're watching Kids Agent, and this video is about the red blood corpuscles, its structure, RBC count in humans, and the death of RBCs. So let's get started. Red blood corpuscles. The scientific name of red blood corpuscles is erythrocytes. Erythros meaning red. Its size is 7 microns in diameter. It is produced in the marrow of long bones, especially sternum, ribs, and ilium of hip bone. Its function is transportation of respiratory gases to and fro the lungs and the tissue cells of the body. So here's a picture of one RBC. Coming to the structure of RBC, it is biconcave disc shaped. Very important keywords: biconcave disc shaped, and lacks cell organelles like nucleus, mitochondria, and endoplasmic reticulum. It contains a respiratory pigment hemoglobin. Without this pigment, RBCs cannot perform its function. In the spongy colorless body of the RBC, that is stroma, it forms the unstable oxyhemoglobin with oxygen and carbaminohemoglobin with carbon dioxide. It's very important that these two compounds are unstable. So here's a picture of top view as well as cross section. Deficient but more efficient. Mature RBCs are enucleate. This makes the shape of the RBCs biconcave disc shaped and also enables the RBC to accommodate more hemoglobin to carry out its function of transportation efficiently. Mature RBCs do not have endoplasmic reticulum, due to which the RBCs become more flexible and it can easily pass through the narrow capillaries. Capillaries are narrow blood vessels. Mature RBCs do not have mitochondria. See, mitochondria is a cell organelle which is the site of cellular respiration. So if RBCs have mitochondria, whenever RBC is carrying oxygen, mitochondria will utilize the oxygen for cellular respiration. So RBCs will not be available for transportation of oxygen as well as carbon dioxide. Therefore, RBCs do not have mitochondria. See, in every point I have mentioned mature. Why mature? The RBCs, when they are initially produced, they have all these three cell organelles. But they lose these cell organelles once they become mature and get ready to perform their function of transportation. Advantages of the size and shape. Biconcave disc shaped increases surface area without increasing the volume. This increase in surface area enables the RBC to absorb more of the respiratory gas that is transporting. It allows the RBCs to pass through the narrow lumen of the capillaries. Diameter of RBC is 7 microns. This small size enables the RBCs to move in a single row through the lumen of the capillaries, and this slow movement enables efficient exchange of respiratory gases. Coming to hemoglobin, that is the respiratory pigment. Hemoglobin is made up of an iron part, hemin, and a protein part, globin. When RBCs are destroyed, the iron atom in hemin is recycled, while the others are converted into bile pigments, biliverdin and bilirubin. The globin part, being a protein, is converted into amino acid. It is then converted into urea after deamination, and the rest is used to synthesize glucose by the process of gluconeogenesis. Gluconeogenesis is the synthesis of glucose from molecules other than starch. Coming to the RBC count in humans. Adult human males have about 5 million RBCs per millimeter cube of blood, while adult human females have about 4.5 million RBCs per millimeter cube of blood. The reason why males have more RBCs than females is the basal metabolic rate of males is higher than that of females. And the body of males is made for strenuous work. That's why their RBC requirement is higher than that of females. Newborns have about 6 to 7 million RBCs per millimeter cube of blood. In newborns, all marrow of all bones produce RBCs. Why this high requirement of RBCs in newborns is because newborns are they have more physiological changes going on inside them. The count is lower by 5% when in sleep and higher during exercise. The count is higher in people living in high altitudes of about 4,200 meter and above. Death of RBCs. Since RBCs are enucleate, they cannot survive for long independently. The average lifespan of RBCs is about 120 days. It is destroyed in liver, spleen, and bone marrow. Bone marrow is the site of production as well as destruction. And in initial stages, in the embryonic stage as well as like in infants, spleen also produces RBCs. In adults, about 2 million corpuscles are destroyed every second, which is about 1% of the total RBC population in the whole body. This is a bone, this is the liver, and this is the spleen. So thank you so much guys for watching this video. Please do like, share and subscribe our channel, and please keep watching our videos. Thank you so much.